Hello everyone, in this class we are starting from the point in which we left in the earlier class, that is the deduction of Rayleigh-Jean's law, Wien's displacement law, Wien's radiation law and Stefan-Boltzmann law from the Planck's radiation formula. So okay, for that I need to share the screen first. Okay, so we ended up here in the last class. Now, from these two formulas, we will now derive the rest four. Case one first, the Rayleigh-Jean's law. So, u lambda d lambda is given by this relation. Now, Rayleigh-Jean's law, as we have already heard, it is valid in the large lambda region. Now, if lambda is very large, then we can say that hc by lambda kt is very small. So if e to the power something is very small, we can expand them as e to the power x equal to 1 plus x square by factorial 2 plus x cube by factorial 3 and so on. Now if x is very small, we can neglect the higher order terms of x. So we can just write e to the power x equal to 1 plus x. So that is why it is written here e to the power hc by lambda kt is almost equal to 1 plus hc by lambda kt. Put it in the formula, this 1 and 1 will cancel, hc will cancel, kt will go up and 1 lambda will cancel. So ultimately we will get u lambda d lambda equals to 8 pi kt by lambda to the power 4 into d lambda, which is the Rayleigh-Jean's law for longer lambda region. Case 2 will be the Wien's law, which is valid for the lower lambda region. Now look at the expression again. If lambda is very small, then hc by lambda kt will be very large, and if it is in the power of e to the power hc by lambda kt, it will be much less than 1. So we can easily neglect this minus 1 with respect to e to the power hc by lambda kt. So u lambda d lambda reduces to 8 by hc by lambda to the power 5 into 1 by e to the power hc by lambda kt. Now 1 by e to the power hc by lambda kt is equal to e to the power minus hc by lambda kt. So for low lambda region or for small lambda values, we get the Wien's displacement law, which was a by lambda to the power 5 into e to the power b by lambda kt. So from here we can get the values of a and b also, where a is 8 by hc and b is hc. So this is another form of Wien's law. Case 3 is the Stefan's law. Planck's radiation formula gives us u nu d nu equals to this one, 8 pi h nu cube by c cube d nu by e to the power h nu by kt minus 1. Now the intensity is given by c by 4 into energy density. Okay, so that is their relation. Now we put it in the formula and get this result. Okay, so multiply it by c by 4. So 1 c cancels and this 8 comes to 2. So 2 pi h nu cube by c square into d nu by e to the power h nu by kt minus 1. Now where e nu equals to c by 4 into u nu. So what will we do? We will integrate it over the frequency, all the frequency. So we will do an integration starting from 0 to infinity and we will get the intensity. Okay, so in the next slide we see that e equals to 0 to infinity e nu d nu. Now you put the value of e nu here and you will get 2 pi h by c square integration 0 to infinity nu cube d nu e to the power h nu by kt minus 1. Now put h nu by kt equals to x. So we get nu equals to kt by h into x and d nu equals to kt by h into dx. Put them in this formula. So you will get a whole constant out, which has already a t to the power 4 in it. And in the integration, we had x cubed dx by e to the power x minus 1, integrating from 0 to infinity. Now it is a standard integration. So you may have done in mathematics. So you just need to know the value, which is pi to the power 4 by 15. So the integration value gives you pi to the power 4 by 15. Put it in the formula, you will get E. So E is given by some constant into t to the power 4. Now this constant is known as the Stephen's constant, and E is equal to sigma 2 to the power 4. T to the power 4 is known as the Stephen's law, where the value of sigma is given by this, which is 5.67 into 10 to the power minus 8 watt per meter square into Kelvin to the power 4. Now we have another law, which is the Wien's displacement law. We can get it from Planck's radiation formula also. So we already know the Planck's radiation formula. U lambda is 8 by hc by lambda to the power 5 into 1 by e to the power hc by lambda kt minus 1. Now Planck's Wien's displacement law states that lambda m into t equals to constant, where lambda m is that particular value of lambda for which EU lambda is maximum. So we have to get the maximum value of u lambda. So you already know, to do maximum or minimum, we just take the first derivative to be 0. So d lambda of u lambda will be 0 for lambda equal to lambda max. Now its derivation is given there. So I have taken capital E lambda instead of U lambda in the notes. You can take both, but must specify which one is what. So at lambda m, E lambda is maximum. So now look at the function. All the lambdas are in the denominator. So if E lambda has to be maximum, the denominator has to be minimum. So we have to just minimize this quantity. That is, we have to find, if I take this as I, so I is equal to lambda to the power 5 into e to the power hc by lambda kt minus 1, and we get di d lambda equal to 0. We get this kind of relation. So you check the formula, you can do it on your own. So 1 minus e to the power minus hc by lambda kt minus hc by 5 lambda kt equal to 0 at lambda equal to lambda m. If you take hc by lambda kt to be x, you get 1 minus e to the power minus x equal to x by 5. Now you cannot solve it easily, so you have to use the graphical method. So you plot 1 minus e to the power minus x along y-axis and x along x-axis one time, and the second time you plot x by 5 along y-axis and x along x-axis. The two graphs where they intersect will give you the point for which these two equations are simultaneously satisfied. And the point of intersection is given by x equal to 4.9651. And we had taken hc by lambda kt to be x. So hc by lambda kt is 4.9651, or lambda m into t is equal to hc by k into 4.9651, which is constant. Thus, we can derive the four laws: Wien's radiation formula, Rayleigh-Jeans law, Wien's displacement law, and the Stephen-Boltzmann law from the Planck's radiation formula. So you just practice it on your own. Now, if you have any problem in understanding the derivations or the physics, you can just ask in the comment section given in the classroom, and we will see about the next topics in quantum mechanics depending on your responses. So you must respond there. Okay, so till now, have a good day. Bye.